Hey folks, welcome to Software Testing Hacks. In this video, let's talk about linked list. So linked list, as you know that it implements the list interface, correct? So let's talk about it today. Before we begin, if you have not subscribed to the channel, please do subscribe to the channel. Let's get started. Linked list is a part of collection framework which is present in java.util package. Specifically, if we want to say java.util.linkedList. So that's how we can, if we import that package, we will be able to access this linked list, all the methods. Okay. It implements list and DQ interfaces. So as I already mentioned, it implements actually list interface as well as some of the uh, you know features or some of the methods from DQ interfaces. So it is a combination of both list as well as DQ interface. Linked list class contain duplicate elements. So as we know that in list can contain duplicate elements, right? As in linked list class can also contain duplicate elements. Linked list class maintains the insertion order, preserves the insertion order, or it maintains, but the way it stores the um, elements is quite different. We will see that in Java, linked list class manipulation is fast because no shifting needs to occur. Suppose if you want to insert lot of data, it is preferred to use linked list. If you want to add or remove any elements, okay, then it is preferred we can use this linked list class. So you can see that this is how it stores, or this is how the linked list we can refer to. Why? Because each element in a linked list is known as node. So whatever you are seeing here, this one particular whatever element is stored in this fashion, where the data will be stored at the center and the previous value or the reference wherever it is pointing will be linked to the this particular address will be stored. Previous address will be stored, and here it stores the next node address. So whatever the previous and then the next I'm talking about is the node address. Okay. So as I said, previous it stores an address of the previous element in the list is null for the first element. Next is something it stores the address of the next element. It is null for the last element. And data, it stores the actual data. So how I'll tell you. So this is one node, this is another node. These are the three nodes that we have. Okay. Let's say that this is the first index, which is nothing but zeroth index. This is in first index and this is in second index. So it doesn't require to be in the same fashion. It can be each node can be at a different place. Even this node can be at this place. So basically, it is a randomized way that it stores. The link will be there. Suppose say it will connect to from zero to first node itself, from first to second node itself. That insertion will be order is there. Okay, but as in compared to the array list, this stores the nodes in a random way. Okay, so as I said, this is the zeroth node, first node, and then second node. If I want to insert any element, so how it inserts is first it will check which is that particular index it goes to. Suppose I have three nodes here, so which is nothing but 0, 1, 2 are the indexes. If I want to add the next fourth one, then it will how it will add is First, it will check the previous one. It will refer to this second node, second index, and then it will store the value. Since there is no further node, it will have the null. So here also the null reference will get changed to the next node, which is the third index. So that's how it gets updated. So here the insertion and deletion is bit easy compared to array list. Okay. So this is how the syntax of linked list is. Linked list, here we have to specify which type we want to use, and then linked list is the constructor name or the object, I would say. So new linked list, this is how the syntax looks like. Okay, so under linked list we have lot of methods as well. So we will see one by one, and practically also we will perform some of the methods operations, but further you can also try by yourself. Okay, so methods. Add is one method, so which we can use to add any element to the linked list. So whatever we saw here, right? So this will create an empty linked list. So we can add using add method, we can insert the elements into this linked list. Get. So get method of the linked list class is used to access an element from the linked list. Okay. Set method. If you want to change any value of the element, you can use this set method. Remove. It is easy. So if you want to remove any of the element from the linked list, you can use this remove method. Contains. Checks if linked list contains the particular element. Suppose in the linked list, if you want to check a particular element present or not, then you can use this method. Index of. It returns the index of the first occurrence of the element. Last index of. It returns the index of the last occurrence of the element. Okay, what is the last occurrence of the element? That it will identify and it will print. Clear. So it removes all the elements of the linked list. Iterator. This is quite important. So why? Because we'll see it. Returns an iterator to iterate over the linked list. Some of the cases you will be asked the question about this iterator. So from interview point of view, it is quite important. Add first. Adds the specified element at the beginning of the linked list. Add last. Adds the specified element end of the linked list. Get first. It returns the first element. Get last. It returns the last element. Remove first in the similar way. Remove last and then peek. This is something different. It returns the first element of the linked list. First in the sense, we'll say the head node. Okay, head. First element, whatever is present, right? That is called the head. Whole. Returns and removes the first element from the linked list. Offer. So this adds the specified element at the end of the linked list. Okay. So these are the methods that we have. Now let's see practically some of the examples. So now we have created a class called linked list demo. So we know that the syntax of linked list is this. As soon as we uh, entered that, we got an error because we have to import this linked list from java.util package. So as soon as we imported it, the error is gone. So here we will say ll, okay, something like that. Okay. So now we have created a empty linked list. Now, if we want to insert any, or let's say we'll add elements, okay, to the linked list. So how to do that? So add is the method that we can use. So here we will write it. So here we'll use this add method. Okay. So how can I add? Linked list ll dot add is the method. So if you type just a or something, if you just hit the dot right here, you will get to see all the list of the methods that it is present in this particular linked list class. So you can use any of them based on your requirement. So now we are just adding a particular string. So we will choose this. Okay. We'll say hello. Okay. In a similar way, let's add few other uh, elements. L dot add string L dot add, let's say, add L dot add, say, Java. Okay. So we have added couple of the elements. So how this will be stored? So this is in the zeroth index, first index, second index, and third index. Okay. Let's print. You can see that all these elements got printed. But now, say you want to add a particular element, okay, at the first position, okay, add here you will get a method called add first. If you want to add it at the first, so here you can use this method and then add, let's say, JavaScript, okay. So now, if you execute this, you can see that JavaScript is added at the first because this add first method here it inserts the specified element at the beginning of the list. So now it is displaying at the first. Okay. So now we will use get method. Okay. So let's say without L dot. So if I want to get, so these are the four methods that we have for get. So you can use, suppose say if I want to get the first element, so just execute this get first. Okay. So it got us it displayed or shown the first element which is present in the list. Okay. So get last, or even you can use if you want to get the fourth index. Okay. Whatever element is present in the fourth index. So you can use the index value also. Okay. Now let's see the set method. Okay. So let's say that let's update the hacks, right? So ll dot set. This is the only method which is available. If I want to set the value, here I can say that this is at the second position. I will change this to software. Okay. Let's print the linked list. Let's see whether it gets updated or not. Oh, the second position, whatever we have is testing. It got updated. So now it is at the third position, right? So I can just update it. Okay. We can see that now hacks got replaced it with software, right? So this is how the set method works. So along with that, let's comment till here. Okay. So I was talking about iterator method, right? Iterator. So here you see that the it is displaying in this fashion, like an index way. Okay, I want to print the values in list. Okay, so how can I do that? Is through iterator method. Okay, so iterator is basically a class, right? Iterator, ITR is equal to ELL dot iterator. So this is the method which we can use. So here you can import this from the java.util. Okay. Yeah. Okay. Now what I can do is I can iterate through this linked list and get the values whatever we have added into the linked list in a list fashion. So now what we have to do is we have to write a while loop. So why we will write the while loop is to iterate through one of elements one after the other. So what we will do is iterator. So we have to see itr dot has next. Okay. We will check has next is a method which will see whether there is any other element which is present after that particular element after printing it. So then we will print this. Okay. ll dot. Now we will print itr dot next. So next is the method which will print the next element in the list. Okay. So we will run this now. So if you want me to explain this again, I will explain it. So iterator is a class. Okay. So we are use performing the iteration on this or iterating on this LL, the linked list. Okay. Here we are created this LL linked list, right? So on that we are performing the iteration. So while has next, right? So we have to check whether, suppose say first it will check that hello is present or not. Okay, one element is present or not. After that, it will check whether there is another element is present or not. So to see that, this has next method will help us. Okay, it returns true if iteration has more elements. Okay, so basically that is the what it does. And now what we will do is we will print out the whatever we have found here, right? So the next element will returns the next element in the iteration. So after printing it, it will like move to the next. Has it will move to the next in this fashion. It will move on. So let's run this. See, it was printed like this in this first attempt, and again you can see there is a difference in how it got printed. So if you're not able to see here, see this is how it got printed. So this is one of the important question. Okay, let's comment this. So what else we can perform? So we can perform the contains method too, right? So this method, let's see ll dot contains, check if it contains Java. Let's write it in the. So it printed true. Okay, if it contains Java, yes, it contains Java in the list, so it returned as true. Okay, so now let's see some of the methods present in the remove. What we will do is ll dot remove. So which one we will remove? We will remove the zeroth index. Okay, and then we will print this list. See that JavaScript is now gone, right? It printed only the remaining four. Okay. Now let's clear out all the elements which are present in this list. So how do we do that? We can simply say there is a method called clear. Here only I'll update. So under remove also we have further methods. If you just notice here, if I say remove, okay, ll dot remove. So under remove, we can use index, object, or you can remove all, remove first. So there are a lot of other remove options as well. You can just explore by yourself some of the other methods. So now we will use clear. Okay. So that will clear all the elements present in this linked list. See, nothing is present now. So we have deleted all the elements. Now we will see what is the difference between array list and the linked list. So here are some of the difference between the linked list and the array list. Linked list implements list, queue, and dequeue interfaces, whereas the array list it implements just the list interface. Those three values, which is like previous address and then data and the next address in a single position, which is known as node, right? Here, it stores single value in a single position, one after the other. Okay, it will store in the form of stack. We can say provides the doubly linked list implementation. Why? Because the link whatever you saw, right, it is doubly linked. How is, if you want to traverse in, if you want to suppose find the fourth element in an array, I told you, right, fourth element in an array, so in the vice versa case also you can perform the uh, searching. Okay, so that's the reason it is like doubly linked. Provides a resizable array implementation. It provides a resizable. Whenever we remove any element, it gets resized. Correct? Whenever an element is added, previous and next address are changed. Okay. So it has to delink whenever we have whenever we remove any element. Okay. It will have to delink that particular address and link it to the next address. It has to get updated. Okay. But whereas in case of array list, whenever an element is added, all elements after the position are shifted. So suppose if you remove element in third position, all the remaining elements present after the third will get shifted one after the other. Okay. To access an element, we need to iterate from the beginning to the element. So suppose if you want to find element which is present in the 100th position, you have to traverse through like 99 times, which is actually kind of disadvantageous in case of linked list. Okay. So because it has to check whatever is in position 0th position, it will check the address, okay, where it is linked. It will find the first, and first will find the second, second will find the third. So like this, it has to traverse and finally find the element which we want. So that's the reason if you want to perform any of the element, if you want to get any of the element, so then it is not preferred to use linked list. Whereas in case of array list, can randomly access elements using indexes. So suppose if you have any process which involves a lot of retrievals of the data which is already present, then go for array list. If you want to insert or delete any data, then go with linked list. So these are the major differences between linked list and array list. So hope this video was helpful for you and you have learned all the things related to linked list. If you have liked this video, please do not forget to like it, share it, and do subscribe to the channel. Thank you for watching. Bye bye.